everyone, it's Mrs. Martello. We're going to look at section 5.3 and I'm on page 248, just so you can see here, 248. All right, in this section we are still solving systems of linear equations, except now we're going to solve by elimination. So when we solve by elimination, I wrote down some steps here that we want to follow. So let's take a look at what I wrote down. I would suggest you pause the video and copy this down into your notes. So the first step is you need to make sure that your equations are in the same form. So we have to have everything lined up. The variables, the like terms, the constants, everything has to line up so that they look like they're in the same form. Okay, that's how we have to start. Then our first step when we start to solve is we want to look for a pair of like terms, so the same coefficients, with, the same variables, with either the same or opposite coefficients. So that means we're looking for the same or the opposite number in front of the variable, okay? If they are the same, then we can continue. If they are not the same number, then we must multiply by a constant to make them become the same number. Once we do that, then we're going to eliminate that variable that has the same coefficient by either adding, if they have opposite signs, or subtracting, if they have the same sign, those equations together. So by adding or subtracting the equations together, that variable is eliminated. Now I'm only left with one variable and I can solve that equation for that variable. Remember that my solution is always an ordered pair. So my last step is I need to take my first variable, plug it in, and find out what the other variable is so I can write my answer as x comma y. Okay, we're gonna take a look at example 1 together here. Okay, we're gonna do example 1. Let's take a look. We have 3x plus 2y equals 4, and 3x minus 2y equals negative 4. We're gonna solve by elimination. So what we want to do first is we want to first notice that they are in the same form. You see how the x's and then the y's, the equals, and then the constants are over here. They're in the same form. That's what we want them to line up with their like terms. Our next step now is to look for variables that have the same coefficient. And actually both of them do. These x's have both 3's in front of them, and the y's both have 2's in front of them, except one is positive and one is negative. So technically we can choose either one. I can choose to eliminate the x's or I can choose to eliminate the y's. Let's imagine we were to eliminate the x's. If I wanted these x's to be eliminated, because they have the same sign, I would have to subtract these two together. 3x minus 3x would get these to cancel out. And then I would have to subtract these terms and these terms. However, subtracting gets a little tricky, especially when you have a negative here. So if I can avoid subtracting the equations, I usually do. So let's take a look at the y's. Look, these y's, I have a positive 2y and a negative 2y. Because these have opposite signs, to get them to cancel out, I would add them together. So I think that's going to be the easier way to go about solving this equation because adding is easier than subtracting. So why don't we choose these y's here? Because they have opposite signs, let's eliminate the y's, and we're going to eliminate them by adding these equations together. When I add, I'm adding everything in the equations. So 3x and 3x, that makes 6x. 2y and negative 2y, they cancel out. Carry down your equal sign. And then I'm going to add these numbers here, 4 and negative 4 equals 0. And look at this, now this equation only has an x in it. Let's solve for x. So I'm going to divide both sides by 6, and I get x equals 0. And I already found my first variable. Let's keep going. Let's find our second variable. I'm going to take the x and plug it into one of the equations and solve for y. It doesn't matter which equation you plug it into, but I'm going to pick the first equation because there were more positive numbers than in the second. So let's take our x and let's plug it in. 3 times 0 plus 2y equals 4. Well, 3 times 0 would just cancel out, and then I can solve for y. We're going to divide by 2 on both sides, and I get y equals 2. Let's write our solution as an ordered pair. So our x that we found is 0, and the y we found is 2, and that is our solution, 0, 2. Remember, you can always check your work. So to show your check, you want to take your point that you found as your solution and plug it into both of the original equations. So let's just double check and make sure this point makes it true. So let's plug it into the first equation. 3 times 0 plus 2 times 2 equals 4. Well, this cancels out. 2 times 2 is 4 equals 4. This one works. Let's try our second equation. 3 times 0 minus 2 times 2 equals negative 4. Again, this cancels out. I would get negative 4 equals negative 4, and this one works as well. Let's do another one like this. We're going to look at monitoring progress number 1. Okay, let me copy this down. I have 3x plus 2y equals 7, and negative 3x plus 4y equals 5. All right, so what I first should notice is that they're in the same form. I have the x's, then the y's, then the equals, then the constant. So I'm good to go with the form that they are in. My next step is I'm gonna look at the variables and look to see which ones have the same coefficient, either the same sign or the opposite sign. And right away, I see that these x's both have a 3. These y's have 2 different numbers. So I'm not gonna go with the y's, I'm gonna go with the x's because they're already the same number, just opposite signs. And actually it's better that they're opposite signs because when they are opposite signs, I get to add these 2 equations together and it makes it easier for me to solve when I can add. Okay, if they were the same sign, I would have to subtract, which is fine too, but just be careful when you're subtracting. All right, so let's add these equations together. 3x and negative 3x are eliminated. Let's keep adding. 2y and 4y would give us 6y. Carry down your equal sign. Let's add these together as well. 7 plus 5 would be 12. Let's solve for y. We're going to divide both sides by 6, and I get y equals 2. Okay, I'm not done yet. I need to still find my x, so I'm going to take the y and plug it into one of the equations. I'm going to pick the first one, 3x plus 2y equals 7. Let's take the y and plug it in. We'll find x. 3x plus 2 times 2 equals 7. We're going to multiply here. 3x plus 4 equals 7. Minus 4 from both sides. 3x equals 3. And then we'll divide both sides by 3, and we get x equals 1. Okay, we're ready to write our answer as an ordered pair. My x is 1, and my y is 2, and that would be my solution. Let's show our check just to make sure that it actually does work here. I'm going to take the point and plug it into both equations. So 3 times 1 plus 2 times 2 equals 7. This is 3 plus 4 equals 7. Yep, that one works. Let's try the second one. Negative 3 times 1 plus 4 times 2 equals 5. This would be negative 3 plus 8 equals 5. Yep, that one works too. Okay, so this is solving, you couldn't see what I was writing over here. So both of them checked out. So this is us solving by elimination just by using addition or subtraction. Okay, both of them happen to be addition because they have opposite signs, but if they have the same sign, you want to subtract. Okay, we're going to take a look at example 2, and in example 2, this is when we're going to have to add an extra layer to it. So if we look at example 2, it says solve the systems by elimination. We have negative 10x plus 3y equals 1, and negative 5x minus 6y equals 23. Now first, notice that they are in the same form, which is a good thing for us. We don't have to fix it and make them in the same form. But what you should notice here is neither of these variables have the same coefficient. These x's do not have the same number in front of them, and the y's do not have the same number in front of them. So if I just added or subtracted these equations together, none of the variables would be eliminated, which wouldn't help us to solve. We need to eliminate to solve by elimination. So this is when we're going to have to multiply by a constant. Okay, so when they don't have the same coefficient, we're going to need to multiply. All right, so now let's imagine, how can I make them become the same number? And when we do this, try to make it so that they have opposite signs so that we can add the equations together. If we can add, again, that's easier than subtracting. So I'm gonna look at the y's because do you notice they already have the opposite signs? Well, this is a positive 3y and this is a negative 6y. Let's keep them opposite signs, but I need to make them become the same number. Well, since 6 is bigger, let's keep the 6 as it is, but what can I multiply by 3 to turn it into a 6? And you're right, that's all we have to do is multiply this 3 by a 2. If I multiply this by 2, this becomes positive 6y, this is negative 6y, and then they would be eliminated. But I can't just multiply just this one term. I have to multiply the whole entire equation by 2. So I'm gonna multiply this first term, this second term, and the third term. Everything gets multiplied by 2. Okay, I'm gonna carry this over here. Let's rewrite the equation multiplied through by 2. This would be negative 20x plus 6y equals 2. And then our second equation, we didn't have to do anything to it. It can stay exactly the same. So I'm just gonna rewrite it so that, again, my variables are lined up. And now look at these y's. These y's have the same number with opposite signs. I'm ready to eliminate these y's. So let's go ahead and add these two equations together and we'll eliminate the y's. So negative 20x and negative 5x is negative 25x, and adding the 2 and the 23 is 25. Let's solve for x. We're going to divide by negative 25 on both sides, and I get x equals negative 1. All right, let's solve for y now. So in order to find y, I'm going to take my x and plug it into one of the equations. And I like to go back to the original ones, but it doesn't matter, but you can choose any of them. I'm going to pick the first one, negative 10x plus 3y equals 1. Let's take our x and plug it in. So this would be negative 10 times negative 1 plus 3y equals 1. This would be 10 plus 3y equals 1. Subtract 10 from both sides. 3y equals negative 9. And we'll divide both sides by 3, and we get y equals negative 3. Let's write our answer as an ordered pair. So my answer would be negative 1, negative 3. Okay, if I wanted to check my solution, again, all I have to do is take my point and plug it back in. And I always want to check in the original equations in case if I made a mistake in multiplying over here, always know that the original equations are correct. So let's do our check here. We're gonna have negative 10 times our x is negative 1 plus 3 times negative 3 equals 1. This would be positive 10. This would be negative 9. Yep, that equals 1. Let's plug it in this one. So negative 5 times negative 1 minus 6 times negative 3 equals 23. This would be a positive 5. This would be a positive 18. Yep, that would equal 23. So I know this one works. Okay, let's do another one like this one. We're gonna do monitoring progress number 2. Let's copy down our two equations here. We have x minus 3y equals 24, and 3x plus y equals 12. Okay, first notice they're in the same form, x, y equals a constant, which is good. Okay, if you're noticing that this is standard form, ax plus by equals c, that is something to notice too, and that was from section 3.4, standard form. So we want to look now at the variables to see if they have the same number or the same coefficient in front of them. These x's, this is technically a 1 in front of here. No, these are not the same. And the y's, again, this is a 1 in front of here. These are not the same. So I need to multiply. Let's decide which ones are we going to make the same. Okay, I'm gonna look for opposite signs. If they already have opposite signs, it's easier to go with that. So I noticed that these y's already have opposite signs, so why don't we go with the y's for this one. Now the 3y is already the bigger one, so let's keep the bigger one as it is. And how can I multiply just y to make it so it has the same coefficient as this? I just have to multiply it by 3. So then this would become a 3y, this would become a negative 3y, and then they would have the same number in front. So let's do that. We're going to multiply this second equation by 3. The first equation is going to stay exactly the same, x minus 3y equals 24. Let's multiply the second equation. We're going to distribute. So 3 times 3x is 9x. 3 times y would be plus 3y. And then 3 times 12 equals 36. Just be careful, don't forget to multiply the constant term at the end. I find people tend to forget to multiply. You're multiplying the whole entire equation by 3, every single term. All right, so now we get to look at these y's. They have the same coefficient with opposite signs, negative 3, positive 3. And now we can add these two equations together. Okay, let's add x and 9x makes 10x. The y's cancel out. Equals, let's add these over here, 24 plus 36 is 60. And let's solve for x. Divide both sides by 10, and I get x equals 6. All right, now that I know what x is, let's find our y. Doesn't matter which equation I plug it into, but I think I'm gonna pick the second equation because this y doesn't have a coefficient, so it'll be a lot faster. So I'm gonna use the equation 3x plus y equals 12. Let's take our x, we'll plug it in. 3 times 6 plus y equals 12. I get 18 plus y equals 12. Subtract 18 from both sides, and we get y equals negative 6. Okay, now I'm going to write my answer as an ordered pair. So my solution would be 6, negative 6. Okay, don't forget to take the time to check your work. You can always take this point and plug it back into both of the equations, and it should make both of them work. You don't have to show your check. You could just do it mentally. Let's do it in our heads. So if this is 6, then negative 3 times negative 6 would be positive 18. 6 and 18 makes 24. That one's correct. Let's plug it in here. This would be 3 times 6 is 18, and negative 6, 18 and negative 6 would be 12. So that one works as well.